Hello and welcome to daily Leetcode challenges. Let's begin our day 33. Okay, question 904, fruit into baskets. You're visiting a farm that has a single row of fruit trees arranged from left to right. The trees are represented in an integer array fruits, where fruits I is the type of fruit the ith tree produces. Okay, so there's a row of trees, each tree produces a different kind of fruit. The kind of fruit that they produce is given to us in an array of fruits. You want to collect as much fruit as possible, obviously. However, the owner has some strict rules that you must follow. You only have 2 baskets, and each basket can only hold a single type of fruit. There are no limitations to the amount of fruits each basket can hold. Okay, so you have 2 baskets, each holding exactly one type of fruit, but there is no limit to how much fruit it can hold. Starting from any tree of your choice, you must pick exactly one fruit from every tree, including the start tree, while moving to the right. So from left to right, the picked fruits must fit into one of your baskets. And fit, the limitation there is not the amount, it's the type. Once you reach a tree with a fruit that cannot fit in your basket, you must stop. Okay, so that means that you pretty much just have to pick out the optimal position to start so that you can collect as many fruits as possible. There could be only 2 types of fruit. Okay, given an integer array of fruits, return the maximum number of fruits you can pick. Okay, so this is pretty heavy description. Let's look at some examples. Fruits 1, 2, 1. Okay, so there's only 2 types of fruit, type 1 and type 2, and since there's no limit to how many fruits can be in each basket, there's 2 baskets, so basket 1 holds 1, basket 2 holds 2. What about this one? 0, 1, 2, 3. So now there's 3 types of fruit. There's 3 types of fruit, and yes, so okay, so it's continuous. You can't pick 0 and then 2, 2. It said here that starting from any tree, you must pick out exactly 1 fruit from every tree. So, okay, let's see. To dumb it down, this must be the longest contiguous subarray with any 2 values. So this is the description for what we have to figure out. The longest contiguous sublist or subarray that only has 2 values. Okay, so what is the first thought that comes to my head, right? There needs to be a sort of I need to almost look at each of the starting points, right? Each of the starting points, and then figure out where that starting point yeah, so if I go the approach of starting from every starting point, can I then iterate through the rest of the array to figure out what is the maximum number of fruits that I would have collected? Let's see. So like for example, for start in range length of the fruits, I would have some sort of um, I would have some sort of data structure that holds the different types that I have, maybe like a set, different types that I have currently passed through, and as long as that number is below 2, I'm increasing the end from start to the end. As soon as I hit the um, as soon as I hit the type increasing or bigger than 2, then I stop, figure out what my max is, what my uh, current longest array subarray is, and move on to the next start. However, that is a O of n squared time complexity because for each um, element in the array, we're essentially running through the array once, right? So that's O(n) squared. What if we could, I'm thinking of sort of like a window approach, a very popular approach to something that has to do with contiguousness in an array or a subarray that's contiguous. What if we start off with one element, with the window essentially being of this consisting of only this one element, and as long as the different types of fruit that we have is less than 2, then we increase the end, so we increase the window by moving the end to the right, and then once we hit that there are 3 types that inside of our window, then we decrease the window by moving the start to the right. That way we would essentially be passing. Okay, so in this way, the start and the end are traversing the array once, which is basically O of 2n, but the 2 is a constant, so it's O of n. And the time complexity there is clearly better. How about we start with that? Um, so what's the idea here? We have a window, right? Let's have a start and an end. Let's have a window being a set, holds the types of fruit that we are currently have inside of our window. And for, I guess I don't need end, for end in range. So what I'm doing here is this is my idea. For end in range length of fruits, that solves the problem of me continuously advancing, increasing the window size. I'm going to actually be adding, increasing the window right here. So for end in range, increase window. However, if the set, the window containing types increases to more than 2, then so if len window happens to be greater than 2, then what we're doing here is saying start plus 1. So we are decreasing the window. And this is actually going to be a while, right? Because we could be in a scenario where we, let's say, I don't know if there is one here, but we could have just added one element from our end that invalidated the first, let's say, 4 elements, right? So we need a while, and let's see, while we're increasing, we would have to check that. Oh, we could check here. Find new max. Okay, so let's first have some print statement that that shows that this is remotely possible. Increase the window, right? So we're increasing the window. Um, we're increasing it. We have some. Let's just uncomment this. While length of window. To window, we're going to be adding continuously the elements that we're looking at. So window, add, and now we need to add the fruit. The fruit is going to be fruits end. And as soon as we fruits start end. Let's just see what this is printing so far. It should almost emulate us. Well, it shouldn't just emulate. It should show us how the window is being generated. And somewhere I must have exceeded the time limit for end range. Yeah. So I'm going to be saying window pop fruits start. Remove. Okay, there we go. So we should be sort of emulating a a moving window. Except what I'm realizing now is the window set isn't enough for us to understand what sort of types of fruits we're holding inside of our window. That is because we could have picked up a specific number of that type of fruit, and just our window size hitting more than 2 doesn't actually necessarily mean that we automatically remove it completely from the window, right? There could still be, for example, if there's 3 fruit of type A and we just added a third type of fruit, then the 3 fruit of type A, they have to be removed one by one, not all at the same time. So we actually probably will be doing a dict here instead. Let's call that a dict, and this will change some of our implementation. The fruits and it's going to be equal to, let's see, window get, this is efficient way to essentially either set a new window key by providing a default value, or just incrementing the previous one by 1. So either way, even if this key doesn't exist, it's going to be equal to 1. If this key already exists, then it's going to be the value plus 1. This is the value, this is the default. Okay, so window plus 1. And here, if we're hitting if we've just hit that our window is greater than 2, then what do we need to do? We need to say fruit is equal to fruits start, and then no, and then window fruit, yeah, I can't type, -1 if window fruit is equal to 0, then window pop fruit. Okay, let's see if now we're hitting more of what we want. We have a 1, a 2, where's the how come on the second pass through we're only printing the second value and not the first one? Did we also increase start there? No way. First pass through we print nothing. First pass through we print nothing. Should we be doing and? Oh, and is not inclusive, so should this be 1 2 1 2 1 2 2 3? Sweet. Okay, do you see what's happening here? There are the things that we're printing are only of one type, or are only at max 2 types. So let's see, is the final thing here to actually just get the max fruits? Let's call it 0, and let's do it. Okay, so this is not needed anymore. We can say that if max collected is smaller than and minus start, then max collected is equal to max minus start. And I'm guessing that we should also have one here. So this is my reasoning, that we need to have one here because we are in the process of increasing windows, and in here, in between this statement and this statement, there are going to be legal fruit collections, and here we need that here for the time when we hit an illegal. Oh, but the illegal hitting here will mess us up here. So after we've hit an illegal element, we need to, or an illegal starting point, we need to adjust it by moving it or decreasing the window. And then we have another illegal one here. Okay, so let's submit this. This should. Great. Awesome. Expected 3. Wait. let's run. Oh, everything is. Do we just need to increase this by 1? And did I have the? I had the 1 plus. So okay. So it's. I don't understand. Max m is equal to n minus start. What is it? Plus 1 here. And if m is bigger than max collected, then get this equal to max. Okay. Okay, not bad. Beating 77%. Okay, so yeah, this window approach is it's pretty commonly used. I remember that what was the longest increasing contiguous subarray was also um, partially very similar to this. We had a window, and the window was based on some condition. We would either be increasing the window by moving the right pointer to the right or the end to the right, or decreasing the window if the condition failed to be met, either jumping it to where the end is now or moving it slightly over by 1. Let's see. If it's hard to tell if this makes sense for me. Seems like a good solution. Let's see. 77 isn't the best. I wonder. I mean, we've gotten 75 before. What are we at? We're at 940. Oh, and this is almost 200 milliseconds. I mean, they have some edge cases here that might increase the time or decrease the time. It's a weird response. Steps until next type, current total, current type. See, no, for some reason the sliding window is just visually so intuitive for me. If like the window is covering exactly, the window is covering a some condition, right? It's built upon some condition. And if that condition holds, then that's a valid window. So I think the purely from the okay, this is interesting. Okay, so this is very concise. Let's look at this one quickly. Answer is just the -1, fruits dict, fruits left. So initializing it to a 0, and then saying for right, which is the end for us, and the fruit, and enumerate fruits. Fruits dict, that's what we did. Length. See, this is so much more readable, and somehow they've um, removed almost 120 milliseconds from this run. They're counting the. I wonder how they're moving the. How are they moving the left here? If len of fruits is greater than 2, so this is very similar to what we had. They are. What is the index? The index is the min of fruits.dict values. So it's finding the. they're keeping track of where the fruit, where each fruit is first encountered. Each type of fruit is first encountered. And when they are removing the index, they know where to initialize the index to right away without without having to iteratively move or decrease the window size. This might be a clever solution here, but still using the same approach, and so I would very much recommend this. It's a little bit more concise, but what they're doing here is instead of the while, they're essentially doing this in an O1, removing the necessity to decrease the window one by one. They do it in O1. But feel free to use this, and thank you for watching. See you later.